In section 1.1, there were some questions about the problems I've circled here. So 36, we're supposed to evaluate this when x is 10. So we have, let's do some simplifying first. We have 4, 3 minus 1 in parentheses times x minus 4. So this is in parentheses, so 3 minus 1 is 2. So we got 4 times 2 times x minus 4. And 4 times 2 is 8 times x minus 4. And we're supposed to put 10 in for the x. So we got 8 times 10 minus 4. And we have to multiply before we subtract. So we get 80 minus 4, which is 76. Okay. Now we're supposed to simplify 39. And we've got 2 times y. So that's 2 y's, y plus y. And then we've got minus and 4 squared. So that's 16 y's. So that's subtract y 16 times. And then subtract 11 more. But not 11 more y's, just 11. So we got 2 y's minus 16 y's. That leaves us with minus 14 y's minus 11. This doesn't have y's, so it can't be combined with the term that has y's. 14 y's minus the number 11. Okay, here we have some number, we don't know what it is, divided by 2 to the third, and 2 to the third is 2 times 2 times 2, or 8, times 64 minus 12a's divided by 6. So this can be over 1, and so we get 64 a's divided by 8. 64 of them divided by 8. 64 is 8 times 8. One of the 8's cancel, so we get 8 a's. And then we have 12 a's divided by 6, and 12 is 2 times 6. 6 is reduced to 1, so we get minus 2 a's. So 8 a's minus 2 a's is 6 a's. All right, 40. 5 L's divided by 3 L's. Well, L is some number, this is times 9 minus 6, that's 3, and that's in parentheses, so we can do that. Just wrote this division this way as a fraction. And L's are some number, and if they're both the same, they would reduce to 1 over 1. If it was 7 and 7, 7 divided by 7 is 1. Or 8 divided by 8 is 1. Or whatever the L's are, they're going to reduce to 1. So we get 5 over 3 times 3, and 3 is understood to be over 1, and when you multiply straight across, so you get 15 over 3, but 3 goes into 15 and gives us 5, leaves us with 5, or these 3's cancels, if you will. When you're multiplying, numerators and denominators cancel. (45). We can't add these because they're not like terms, but we can distribute, and it's an exception to the order of operations. So we take 9 times the y, the 9 times the 8, minus 27. Now, these have y's, 9 times a number, but this is just a number, and this is just a number. So these are two numbers that can be put together. Can't be put with the 9 y's, because this is just saying how many y's are added. There are 9 y's added, y plus 9 times. And 72 minus 27, I believe, is 45. And that's the ones that I had question was on that page, and then 57 and 58. Now, it's often helpful if you're doing word problems like this, if you can draw a picture for yourself, it's can be helpful. So there's a mound of G pounds of gravel. And then throughout the day, 400 pounds of gravel are added. So we're going to get plus another mound added to it of 400 pounds. But also there's 2 orders of 600 pounds. Well, there's not enough in this mound, so I'll just assume we're taking 2 orders of 600 pounds. So that's 600 pounds and another 600 pounds, or if you will, 1,200 pounds are going to be taken away. So an equation that would describe this, and at the end of the day, there was all this put together is 1,200 pounds. So there was G pounds plus 400 more pounds minus 1,200 pounds taken away in 2 loads of 600. So you could go 2 times 600, if you will. And that left a pile. After all this was done, there was 1,200 pounds. So 400 minus 1,200 is 800 taken away. There was 400 added. 400 added and 1,200 taken away. So there's a net of 800 taken away from the original pile. And that left a pile of 1,200 pounds. So if we take and add in what was taken away net, we get that the original pile must have been 2,000 pounds. That's the answer to G, or 58, and this is what they were asking us to set up. Okay.